Hello, my name is Robert Behrens. I will be doing this project 1 for fluids. So right now we're in Ansys, the workbench. We're going to come over here, click fluid, and drag it over here. So to start, we want to set up our geometry. We are going to do new design modeler. That's going to load. Alright, so we're going to be looking from our z-axis. We'll go to xy plane. We're going to go to sketching. So we want a rectangle. What we're going to do is we're going to draw that straight from the origin. There we go. And we're going to go up here to units, and we want to be in millimeters for this project. So we want to set our dimensions. We're in general. There, V1, H2. So our horizontal and our vertical height, dimensions. For our vertical, we're going to do 10 millimeters, and for our horizontal, we will do 200 millimeters. Very small, so we're going to zoom in. There's a little rectangle right there. So we're going to go up here to concept. We're going to do surfaces from sketches, and we want to get our box select out. We'll select all of these lines and apply. Now we have a surface that's going to generate. And with the surface, we can go back to workbench, go to mesh. So now we have our mesh. So we're gonna go over here, right click mesh, insert method. We're gonna select our face, apply that. Go back here, insert sizing. And from here we want to do our edges. So this would be our inlet, this will be. We're going to hold down Control, select what will soon be our outlet. We're going to apply. We want to do number of divisions, and we will be doing 150 divisions. And we're going to change capture curvature to no. Make our behavior hard. And we're going to generate. So now we see our mesh is like this, not ideal. So we're going to go back here. We're going to do sizing once again. And we're going to select this edge and this edge. Oh, Control. There we go. Apply. Same thing. Number of divisions, except this time we want to do 400. Again, capture curvature, no. Behavior, hard. And we're going to generate. Down here you can see it's meshing. So wait for that so we could see it. Alright, so obviously again still not ideal, not what we want for our meshing. So again we're going to right click on mesh, and we're going to insert face meshing, and we're going to select this face. We're going to apply. And then we'll generate one last time. right. So we zoom in. Very nice looking mesh. All right. So we're done meshing. We're going to define our boundary conditions. So we're going to make sure edge select. We're going to select our inlet edge. And what we want to do is we want to name it. So press N, we can name it inlet. We're going to do that for every edge. So here we have the outlet. This is going to be our top wall. And then we have our bottom wall. All right. So now we're going to go back to Workbench. We're going to right click on mesh. We're going to do update. Now we can go to setup and make sure double precision is enabled. Start it. Okay, so we're going to make sure type is pressure based, time is steady. So that's all good. We're going to go to models up here, and we're going to go to viscous. Okay, so we're going to be doing laminar for this project, so we're just going to select laminar. And of course, when we get to our viscosity and other values, we're going to make sure Reynolds number stays laminar. So we're now go to materials. Under fluids is air. So here we're going to change our density to 1 and our Reynolds number to 0.0001. We're going to change / create and close. Go here to cell zone conditions, surface body, and we're just going to make sure that air is our material and that everything's correct, so which it is, and we are good. Now we're going to go to boundary conditions. We're going to go to inlet, edit, and we want our velocity magnitude to be 3 meters per second. Now we'll go to outlet. We want to make sure our gauge pressure is 0, which it is. And for our outlet, we want it to be pressure outlet, and for our inlet, we want it to be velocity inlet. So now we're going to go to our top wall, edit. Wall motion should be stationary, which it is. Check bottom wall as well. All right, we're good here. So now I'll go to reference values. Just check that our velocity is 1, or sorry, check our viscosity and make sure it's correct, which it's not. Oh, you know what? Got to make sure that we're at the inlet. So now that we look at that, velocity is correct and viscosity is correct. So that's all good. Now we're going to go down here to initialization. We're going to initialize. Now we want to go to run calculation, and we want 500 iterations. That should be sufficient for this, and we're going to calculate. All right, calculation complete. Now we're going to go back to Workbench. We're going to see our results. So we'll go back here. And right now it's blank, so we need to actually add our contour. And we'll call this velocity. So we want our location to be symmetry 1. We want our variable to be velocity u. And then we want 50 contours. We're going to apply that. Now we can actually see how our flow looks. Now what we want to do is we want to edit this legend because it's right in the way and it's kind of ugly. So edit, we will do horizontal. We want our appearance, we want our size to be 1. Let's set our aspect to 0.05. We want precision to be 1, and we're going to make it fixed. All right, that looks pretty good. So we applied. Now we want to get a velocity profile. So what we're going to need to do is make a whole bunch of lines through there, which will be able to analyze and give us our profile. So what we're going to do is we're going to go to Insert, Location, Line. We'll just call it. We're going to make 4 lines. So what we'll do is we'll start at 50 millimeters. Just name it 50 millimeters. Okay. So 0.05 here. 0.05. And we're going to do 0.01 for our Y. And we will do 100 samples. Apply. Now nothing happened, but if we remove our contours, we can see a line right there. Now we're going to do this 3 more times. 1 at 100, 100 millimeters, 0.1, 0.1, do 0.01 again, 100 samples. Apply. Second line. 150 millimeters. Apply. There's 150. And then we want one at the very end. .200 millimeters, because that's where it ends. So we'll do 0.2, 0.2, 0.01, and 100. Okay, there we go. So our lines are set up. We're going to apply, which we already did. So now we want a chart. We're going to click up here at chart. Call this velocity. Velocity profile. And then we're going to change this, make sure it's XY line. We want the title to be velocity profile. What we're going to do is we're going to go to data series, and then we'll start adding in the data from the lines that we just made. So we'll do 50 millimeters. Location is going to be our 50 millimeter line. And then we're going to go over here. Going to make this velocity u for our x, and then for our y, it's just going to be y. Going to apply and get a line. So now we're just going to do that again. Make a new line. We're going to call this 100 millimeters. We're going to go to our 100 millimeter line. And these should be the same. Yep. We apply, get another line. Add another one. 150 millimeters. 50 milliliters, then we add one more, 200 milliliters, 200 milliliters, apply. And there we go, there's our velocity lines. So now we're going to go back to our 3D viewer. We can add our contour lines back because we don't need to see those data points. And that's it for our first part of this project. Now we need to do the Couette flow. So we're going to go back over to setup. And we're going to change our Reynolds number. We want a higher Reynolds number, so we're going to go back to air. Change that to 0.01 for our viscosity. And then we can go over to boundary conditions. We want to make our inlet, pressure inlet, 0, that's fine. We don't want any flow going through the inlet because that's not what this type of flow is. Then we go to our top wall. And now this time we want to make sure this is a moving wall, in wall motion. And what we're going to do is we're going to set this to 1 meter per second. We're going to apply. I missed one part. We want to make our translation 1. It is. Okay. So that's good. And now we're ready to initialize and run. So we'll right click here, initialize and calculate. Alright, calculation complete. Now we can go back to our results tab. We're going to refresh. And that looks like Couette flow. So our top wall is moving. We can go to our chart. The chart hasn't refreshed. And that's exactly what we want. We want a just linear line. The 50, 100, 150, and 200 are all right on top of each other. If I deleted these, then it would show that they're just right under another. But I'm not going to delete them because it would be annoying to make them again. And that's how it should look. And what we can do here is we can change our precision of our legend right here. If I can find it. Oh, there we go. So we're going to change our precision. We could make that 2. Get more, even make it 3. Get more of an accurate reading as to what we're actually looking at velocity-wise. So very high flow, or very high velocity at the top. Gets lower and lower as we go down, which would make sense because only the wall is moving. That top wall, that is. So now we're going to do our combined flow. So we'll go back to setup. We're going to go back, and we want a higher Reynolds number now. So we're going to go back to our material, select air, and we'll make this back to 0.0001 for our viscosity. Close that. Going to go to boundary conditions. And of course for combined, we want that moving wall. And then we also want our inlet to have velocity. So we're going to make this a velocity inlet once again. And that's going to pop up. And we're going to put this right back at 3 meters per second, which it is. And then top wall, we can go back and edit that. We want this to be 3 meters per second as well. And then we'll just run the calculation. And the reason why I chose 3 meters per second is because when you calculate the Reynolds number, and you use the Reynolds number to calculate the formulated flow. That's not the word for it. It's fully developed flow. So when the fully developed flow is at 0.18 meters with this Reynolds number, and the length of our sample is 0.2 meters, so 200 millimeters and 180 millimeters. So the developed flow is right around here, which is pretty good for us. So we get a pretty good view of what's going on here. Go back to chart, still not updated, and that's our flow. So that's the end of this project, and that's it. Thank you.